My name is Tawfiq Omer Osman, teacher of mathematics. In this video from the Mathematics for All Grade 12, Chapter 1, Lesson 1, Graphs and Linear Models, I will explain the part A, sketching the graph of the function using point. Let us start the lesson. Sketching graphs. To sketch the graph of the function using point plotting, follow these steps. Step 1. Create a table value for a variable x and y. Step 2. Choose some values for a variable x from the domain of the function. Step 3. Replace x values in the equation of the function and find y values. Step 4. Plot the points in the coordinate plane. Step 5. Connect these points with an appropriate curve. Sketching linear functions. We have two types of graph for linear function. The first type is when the x sign is positive, then its graph increases as we move from left to the right. Fx equal ax plus b is the equation of the linear function when a is slope of a line and b is intersection with the y-axis. If a is bigger than 0, the function increasing when we are moving from left to right. The second type is when the x sign is negative, then the graph decreases as we move from left to right. When a is less than 0. The line decreasing when we are moving from left to right. Example, question number 1. Sketch the graph of the function fx equal minus 1 over 2x plus 2. As you can see that the x sign is negative, then the graph of the function will be decreasing when we are moving from left to right, like this. And now, first of all, let's take some value for the variable x. Let x be 0, y equal fx equal minus 1 over 2 times 0 plus 2 is equal 2. And the first point is 0 and 2. This is 0, 1, 2. This is the point 0, 2. And now we can draw the line decreasing, as you can see. Another one can draw like this, and like this, and like this, and like this. That means one point is not enough for drawing a line or a linear function. We need more points. Then we must take more points, because f is a linear function. To draw its graph, we need only 2 points. Only 2 points. Let x equal to 2, y equal f of 2 equal minus 1 over 2 times 2 plus 2 is equal 1. We are cancelling this 2 with this 2. Remain here minus 1. Minus 1 plus 2 is 1. And now the second point, we have 2 and 1. 2 and 1 here. We can see that the black line passing through the 2 points. That means this graph is the graph of the function f(x) equal minus 1 over 2x plus 2. Sketching quadratic function. We have two types of graph for quadratic functions. The first type is when the x square sign is positive, then the function is open to the top. The equation f(x) equal ax squared plus bx plus c is the equation of the quadratic function. If a, that means the number before x squared, is bigger than 0, then the function is opening to the top like this, and this point is called a vertex. To find x of the vertex, we use this rule, minus b over 2a, and this function will be concave. The second type is when the x squared sign is negative, then the function is open to the down. If a is less than 0 or smaller than 0, then the function will be opening to the down like this, and the vertex finding it as we talked before. And this function is convex. Example number 1. Sketch the graph of the function f(x) equal x squared minus 2. You can see that the sign of x squared is positive, then the function will be open to the up like this. And to find the vertex, we must use the rule x equal minus b over 2a. Here b is 0 because we haven't any x. We have x squared, but we haven't x. Because of that, the b is 0 and a is 1. Then x equal minus 0 over 2 times 1, which equal 0. Then to find y, replace 0 in place of the x in the function of the f(x). Y equal f of 0 equal 0 squared minus 2, which equal minus 2. When x is 0, y is minus 2, then the vertex is 0 minus 2. 0 minus 1 minus 2. Here is the vertex 0 minus 2. As we know that function is opening like this, so we can draw the curve like this. But another people can draw like this, and another like this, and like this. So we know that one point is not enough for drawing a curve of the function f(x) equal x squared minus 2. Because of that, we must take more points. The first one, let x be minus 2. That means we take 2, another value at least, one smaller than 0 and one bigger than 0. Then find y equal f of minus 2, which equal minus 2 squared minus 2. Minus 2 squared is 4. 4 minus 2 is 2. Then y is 2, and the point is minus 2, 2. We are taking another value for the variable x. Let be 2 bigger than 0. Then replace it in the function y equal f of 2, which equal 2 squared minus 2, which equal 2. Then 2, 2 is another point. And now we have 3 points. 0, minus 2, minus 2, 2, and 2, 2. Plotting this point, we can see here is minus 2 and 2. Here 2 and 2. We can see only the red graph passes through the 3 point. that is the correct curve of the function of fx equal x squared minus 2. Sketch the graph of the function fx equal 1 minus x squared. Because the sign of x squared is minus or negative, then the graph will be open to the down, like this. And to find the vertex using the same rule, x equal minus b over 2 times a, here b is 0 again because there is no x here, and 2 times a is minus 1, 2 times minus 1, then the 0 over minus 2 is equal 0. And now we must take another 2 points for drawing the graph. First of all, we must find y equal f of 0, which equal 1 minus 0 square equal 1. Then the vertex is 0, 1. And now we must take to another point. Let x be minus 2. Y equal f of minus 2 equal 1 minus minus 2 square. Minus 2 square is 4. 1 minus 4 is minus 3. Then y is minus 3. A new point is minus 2 minus 3. Let x be 2. Then y equal f2, which equal 1 minus 2 square. 2 square is 4. 1 minus 4 is minus 3. Then the new point is 2 minus 3. Plot these 3 points on coordinate. This is minus 2 minus 3. This is 2 minus 3. And this one is 0, 1. And draw the graph like this. This is the graph of the function fx equal 1 minus x squared. If the quadratic function is written in a formula fx equal x minus h squared plus k, fx equal minus x minus h squared plus k, fx equal h minus x squared plus k, and minus h minus x squared plus k. In all of them, a vertex is hk. Because the outside the bracket is positive here, then the graph will be opening to the top. And here is negative, then the graph will be opening to the down. Both of them, the vertex is hk. Example, sketch the graph of the function fx equal x minus 3 square minus 2. Compare the function with the function fx equal x minus h squared plus k. We can see h is 3 and k is minus 2. The 3 minus 2 is the vertex of the function. And now we must take to another point. Take h equal 3 in the middle and take to another value for the variable x. One of them smaller than 3 and the other is bigger than 3. Smaller than 3 is 2 and find y. f2 is equal 2 minus 3 square minus 2. 2 minus 3 is minus 1. Square is 1. 1 minus 2 is minus 1. Here is minus 1 y. Then the new point is 2 minus 1. Let's take a value bigger than 3. Let be 4. Find y. F of 4 equal 4 minus 3 square minus 2 is equal minus 1. And now plot the point on coordinate. 2 minus 1 and 4 minus 1. And this is the graph of the function fx equal to x minus 3 square. Another example, sketch the graph of the function fx equal minus x plus 3 all square plus 2. Because of what? First of all, compare the function with the function fx equal minus x minus h squared plus k. H here is minus 3 and k is 2. Then the vertex is minus 3, 2. Let h is minus 3 in the middle. Then take a value for x smaller than minus 3 and a value bigger than minus 3. Smaller than minus 3 is minus 4 and bigger than minus 3 is minus 2. Find y. F of minus 4 equal minus 4 plus 3 square plus 2. Minus 4 plus 3 is minus 1. Minus 1 square is 1. Then minus 1 plus 2 is 1. Minus 2. F of minus 2 is minus 2 plus 3 square plus 2. Minus 2 plus 3 is 1. 1 square is 1. Minus 1 plus 2 is 1. And now draw the point. Minus 4, 1, and minus 2, 1, and minus 3, 2. This is the graph of the function fx equal minus x plus 3 square plus 2. Sketching graphs of square root function. When the x sign under the square root is positive and the square root sign is positive 2, then the equation fx equal to square root of x minus h plus k, the graph will be starting at the point hk and to the right and up, to the right and up like this. But when the x sign under the square root is negative and the square root sign is positive, then fx equal square root h minus x plus k starts at hk and to the left up, to the left and up. When the x sign under the square root is positive and the square root sign is negative, it will be to the down from the hk and down right, down right. When the x sign under the square root is negative and the square root sign is negative 2, then the graph will start at hk and to the down left, down and left. Example: sketch the graph of the function fx equal square root of x plus 1. You can see the sign of x is positive and the sign of square root is positive 2. Then the graph will start at hk to the right and up, to the right and up like this. This is the graph of the function. Solution: compare with the fx equal square root x minus h plus k. You can see that h is 1, but we haven't any number adding to the square root. Because of that, k is 0. K is 0. Then the start point is minus 1, 0. Minus 1, 0. And now we must take more points. At least we must take another 2 points. But because we have minus 1 and the sign of x is positive, then we must take value bigger than -1. Then -1, and we take 0 bigger than -1, then 3. You must take a value for the variable x which have a square root. And now find y. Y equal f of -1, which equals square root of -1 plus 1, which equals 0. Then -1, 0, the first start point. Y equal f of 0 equal square root of 0 plus 1 equal 1. When x is 0, y is 1. Y equal f of 3 equals square root 3 plus 1. 3 plus 1 is 4. Then square root of 4 is 2. Another point, 3, 2. And now plot the points and coordinate. This is -1, 0. This 1, 0, 1. This is 3 and 2. And draw the graph like this. This is the graph of the function fx equals square root of x plus 1. Example, sketch the graph of the function fx equals square root of 1 minus x. Solution, compare with fx equals square root x h minus x plus k. Then h is 1 and k is 0. And now to know that how to take the value of x, take under the square root bigger or equal to 0 and find x. X is less than or equal 1. This is the way. We have another way, because the sign of x is minus or negative, you can take a number smaller than 1. Smaller than 1. And because here we have an sign minus and here is positive, then the graph will be like this. From the start point to the left up. From the start point to the left up. And now the start point is 1, 0. X and y, we must take value less than smaller than 1, then -3, 0 and 1. Find the y. Y equal f of 1, which equal square root of 1 minus 1 equals 0. And y equal f of 0 equal square root of 1 minus 0 is 1. Y equal f of -3 equal square root of 1 minus -3. -3, that means plus 3. 1 plus 3 is 4. Square root of 4 is 2. And now plot the point on the coordinate. You can see that graph will be like this. Drawing the graph like this. Example, sketch the graph of the function fx equal minus square root 3 minus x plus 2. Solution, compare with the fx equal minus square root h minus x plus k. We can see that h is 3 and k is 2. Because the sign of the x is minus and the sign of the square root is -2, then the graph will be starting from the start point to the down and left, to the down and left. H is 3 and K is 2. Then the start point is 3, 2. Take under the square root 3 minus x bigger or equal to 0, which equal x less than and equal or equal 3. That means we must take a value for the variable x less than 3. X and y, we must take minus 1 and find y. Y is equal f minus 1 equal minus square root 3 minus minus 1 plus 2. Minus minus 1 is plus 1. 3 plus 1 is 4. Square root of 4 is 2. Minus 2 plus 2 is 0. And now we take 2. Y equal f of 2, which equal minus square root 3 minus 2 plus 2. 3 minus 2 is 1. Square root of 1 is 1. Minus 1 plus 2 is 1. And now we must take 3, which give us 2. And now plot the point on coordinate. And now we draw from start point to the down and left like this. Start point to the down and left. Drawing graph of absolute value functions. When the x sign inside absolute value is positive or negative and the sign of outside is positive, then the graph will be like this, and this is the vertex of the absolute value. To find the vertex of the absolute value, take inside the absolute value equal to 0 and solve the equation and find the value of x. Then replace the value of x in function and find y. When the x sign inside absolute value is positive or negative and the sign of the outside is negative, which fx equal minus square absolute value of x, fx equal minus and minus x absolute value of x. The graph will be drawing like this and find vertex as we said before. Example: sketch the graph of the function fx equal absolute value x minus 2. To take a value for the variable x, because first of all take inside the absolute value equal to 0 and find x is equal to. To find y, and we must take another value for the variable x, less one of them is smaller than 2 and another is bigger than 2, 1 and 3. And now find y. Y equal f2, which equal absolute value 2 minus 2, which equal 0, and y equal f of 1, which equal absolute value 1 minus 2 equal to 1, and y equal f of 3 equal absolute value 3 minus 1 equal 1. And now draw the points on the coordinate. This is 1, 1. This is 1, 2, 0. This is 1, 2, 3, 1. And then draw the graph of the function like this. Sketch the graph of the function fx equal minus absolute value x plus 1. Solution: first of all, because we have x inside the absolute value, then we must take 0 in the middle, and a number less than 0, minus 1, and another value bigger than 0, and find y. Y equal f of minus 1, which equal minus absolute value minus 1 plus 1 equals 0, and y equal f of 0 equal minus absolute value of 0 plus 1 equal 1, y equal f1 equal minus absolute value of 1 plus 1 equal to 0. And now we have 3 points, minus 1 0, 0 1, and 1 0. Minus 1 0 is here, this is minus 1, this is 0, 0 1, this is 0, and this is 1, and 1 0 is here. And now we will draw the graph like this. Another example, sketch the graph of the function fx equal minus 2 over x minus 1. Solution. First of all, take x minus 1 equal to 0, x equal 1. We must not take 1 as a value of x, but we must take 3 value smaller than 1 and 3 value bigger than 1. The 3 value smaller than 1 is 0, minus 1, minus 2, and 3 value bigger than 1, 2, 3, 4. And then find y. Y equal f of minus 2 equal minus 2 over minus 3, which equal 2 over 3. Y equal f of minus 1 equal minus 2 over minus 1 minus 1 equal minus 2 over minus 2, which equal 1. Y equal f0, which equal minus 2 over 0 minus 1 equal to 2. And the others is minus 2 and minus 1 and minus 2 over 3. And now plot the point on the coordinate. First of all, we must draw a line x equal to 1, x equal to 1, which calls vertical asymptote. And now the part of the function will be in the left side and another part will be in the right side. Draw the point like this, and the part of the graph will be here, and the second part will be like this. This is the graph of the function. Question 8, revision. Sketch the graph of the function fx equal 7 minus 6x minus x square. Because the sign of x square is minus, then the function will be drawn like this. Here is a vertex. We must find the first a vertex. To find a vertex, comparing with the fx equal c plus bx plus x square, we find that c is 7 and b is minus 6 and a is minus 1. First, find the vertex of the parabola. To do that, use the rule x equal minus b over 2a. Then x will be minus 6 over 2 times minus 1 equal minus 3, less than minus 3 and bigger than minus 3, minus 6 and minus 3 and 0. Find y. Y equal f of minus 6 equals 7 minus 6 times minus 6 minus 6 square. minus 6 times minus 6 is plus 36, and minus 6 square is 36, then plus 36 minus 36 cancelling, it stays 7, then y is equal 7, and then minus 3 is 16, and when is 0 is 7. And now draw the point on the coordinate like this: minus 6 7, minus 3 16, 0 7, and the function will be drawing like this. And now we have an example as an option. Which of the following graphs represent the graph of the function fx equal x squared plus x minus 2? We have the sign of the x square here is positive. That means the graph will be opening to the up. That means A and C are not the graph of the function. And now we must know which one, D or B, is the graph of the function. We must search for the vertex. First find vertex of the parabola. To do that, use x equal minus b over 2a. You can see a is 1, b is 1, then x will equal to minus 1 over 2 times 1, which equal minus 1 over 2. You can see the vertex here is, x of the vertex here is 0. This is the vertex, this is the vertex, and the x is 0. And here this is a vertex, and the x is here minus 1 over 2. That means the b is the graph of the function, not d. Or in another way, when we find the x of vertex, find y, then y is equal minus 1 over 2 plus minus 9 over 4, and then find the vertex in D and B. In D is 0 minus 2, in B is minus 1 over 2 minus 9 over 4. And this is mean that the right answer is B, not D. Which of the following graphs represent the graph of the function fx equal minus square root of x? As we know that because the sign of x under the square root is positive and the sign of square root is negative, then the graph will be drawn in the start point to the down and right, to the down and right, like this. This means that A is not a solution and C is not a solution. Remain only D and B, D and B. Because x is 0, if we take under the square root equal to 0, then x will be 0. And to find y is equal to 0 too, then the start point is 0 0. The start point will be 0 0. This is the start point is 1 0, and this is the start point is 0 0, so that the B is the correct answer. Homework: sketch the graphs of each functions below. And now we reach the end of the lesson. Please do not forget your like and your comments. Thank you for watching and goodbye.